Good afternoon, everybody. We're going to go ahead and get started today. Today is going to be quite a bit different than some of our previous classes, but I think it's going to be really good for everyone. So your Chapter 3 test retakes are tomorrow. You must do the retake assignment in Canvas in order to retake the test. So if you have not done that already and you want to do the test retake tomorrow, please do the retake assignment. Tomorrow is a late start day, Friday, late start as usual. So period 3 will begin at 12:52 p.m. tomorrow. Make sure you show up on time, because if you show up late or at the wrong time, you may cheat yourself out of time to do the test retake. Chapter 4 test is on Tuesday. We will do a review together on Monday, and then you'll take the test on Tuesday. Finals are April 1st and 2nd. And finally, extra credit available today for speaking up during class. I will give you some more details about that in just a second. All right, let's go over to Canvas here, and we are on Thursday. I believe that you've already watched the Student View courses instructional video, so you do not need to watch that again unless you want to and you missed something and you want to see it again. So that's staying right there. All right, so the first thing that we're going to do today is we're going to do a little bit of a review discussion. So in order to encourage participation and to have a more fruitful discussion for everyone, there's extra participation credit for anyone who unmutes their mic and asks or answers a question. You will be given credit based purely on speaking, not on being correct. These are real points that will increase your overall grade. As usual, excuse me, please be respectful when others are speaking. Ms. Schmitz is on hand to keep track of the people who talk. So just unmute and say your answers or ask a question. So we're going to go over to here. So on this graph, I have a quadratic equation that's been graphed. So it is a parabola. So who can tell me the coordinates of the vertex of this parabola? We're looking for the coordinates of the vertex. There are coordinates for 4 points on the graph. 1, 7 is close, but not what we're looking for. You got one of the numbers.
3, 7.
3, 7 is correct. Very good. Okay. So, still looking at this graph, who can tell me one of the x-intercepts, the coordinates for one of the x-intercepts?
.3 and 0.
That is close. In fact, I'll give it to you. We're looking, that's the point over here, 0.354 and 0. Yeah, on these points though, try not to round up. All right, who's got the other point, the other x-intercept?
Is it 0.2?
That is actually the y-intercept. because that's where the parabola crosses the y-axis, which is the up and down, the vertical line. Do you want to take a shot and do you want to take another shot at it?
Is it 5, 6?
Yes, the 5.646 and 0. That is the other x-intercept. Good job so far. So now we're going to go over here and we're going to review yesterday because there's a lot of steps involved in using the quadratic formula to solve these quadratic equations. And your async homework for today it's quite a bit more involved than what you're used to. And so I want to make sure that you guys are solid on using the quadratic formula. So the first thing we want to do is we want to identify a, b, and c in this equation, the 2x squared plus 3x minus 20. So what is a in this equation?
Is it 2x squared?
That is close. So when we're identifying, you got the right term, but when we're identifying a, b, and c here, we just want the coefficients. We just want the number that's multiplying the variable. Yes, 2.
Okay.
All right, so who has b?
Is it 3?
Yes, it's 3. And that means that c is
-20.
-20. There we go. Okay, so now we're going to plug these numbers into this formula, quadratic formula up here on the top right. So the first term that we're going to write down is going to be what? What number?
3.
Yes, but look at the formula. That 3 should be
-3.
-3. Excellent. Plus or minus the square root of, what is this term here, this first term under the radical?
Three squared.
3 squared. Excellent. 3 squared minus 4. This 4 is free. This 4 is always going to be here when we're using this formula. Times
2.
2. Very good. And the last part.
-20.
Minus 20. Someone tell me what the denominator is.
2 times 2.
2 times 2 is correct. All right, so now these are the problems you were solving the other day. Oh, I didn't put my right parenthesis there. So on whatever day that was, Tuesday, on Tuesday, we were doing these problems from start to finish. All right, so the first, so I think I have this on the next page. Ah, look at that. So the first step in solving these is simplifying under the radical. So I'm just going to bring down this -3 plus or minus square root. All right, so when we're simplifying under the radical, remember we're doing it in 2 parts. We're doing the term with the exponent, and then we're combining that with the term with the rest of the numbers multiplied out. So what's the first term that we need to calculate? What?
The 3 squared.
And that turns into
9.
9 times 3 is 9. So then we have the second term. So what is the second term?
160.
That is correct. So -4 times 2, which is 8, -8, times -20 equals 160. We are adding these two terms together and we get 169. Oh, that's 199. What am I doing? 169 over, someone tell me the denominator here.
4.
4.
4. Very good. Now you may remember this as where we left our second example yesterday. So now we're gonna go further. Now we're gonna finish this and get to 2 answers, and that will be, we'll have completely solved the quadratic equation. Oop. There we are. So here we have our equation at the top. And to finish this out, just like the video said yesterday, and I believe I mentioned it yesterday, we're just splitting it into 2 equations. We're no longer dealing with this plus or minus sign. We're doing the plus part and we're doing the minus part, and then we're solving them individually. So now what I want you to do for this is go to the Desmos Scientific Calculator. There is a link in Canvas, and I'm going to put a link in the chat as well. So go ahead and open up the calculator. And it's important that you're able to fully utilize this calculator to enter in these types of complex expressions, because you're going to be able to use this calculator on a lot of your state tests. So it's going to be much better for you if you can evaluate these easily. So what I want you to do is, in the Desmos calculator, I just want you to put this in and evaluate it. And once you get the answer, and I think in the Desmos one, you don't even have to hit enter. It calculates it automatically. So once it gives you an answer, I want you to put it in the chat, but do not hit enter. I'll tell you when to hit enter. So what you're doing, you're calculating the left expression, the -3 plus square root of 169 over 4. You're entering it into the Desmos calculator. You're getting the answer, you're putting the answer in chat, and not hitting enter. So I'll give you a bit of time to get that worked out. Okay. Oh, my goodness. Hold on 1 sec. Dropped my stylus. Do we have the answers? Answers ready? Yes or no? Tell me somebody has an answer ready.
Yes.
Awesome. Press enter. Ooh, someone solved both. Awesome. 2.5 is correct. So first, I'm going to work this out to verify that, that the Desmos calculator is not lying to us. Although I am going to use it to figure out the square root. Square root of 169 is, of course, 13. We're back into here. -3 plus 13 over 4. So that simplifies to negative 13. Yeah, negative 3 plus 13 is 10 over 4, which is 5 over 2 when we simplify it, which is exactly the same as 2.5. So you all were correct. Now I'm going to show you how to do that purely on the calculator. Now, when I'm putting in complex expressions like this into this calculator, sometimes I get messed up. So I want to show you what you could do to make it easier on yourself. I like to put the entire numerator in parentheses. So I'm going to start by clicking the left parenthesis button, and then we're going to do negative 3 plus the square root of 169. And now I'm going to click this right arrow key. I click the right arrow key and it gets us out from under the radical. And then I'm going to put the right parenthesis. And now I'm going to divide by 4. And we get 2.5. That can be helpful because a lot of times the cursor will just stick inside a square root or other type of symbol. And you really want to get the whole grouping. Okay, so now I want you to work out the other expression in the calculator, the negative 3 minus square root of 169 over 4. And same deal, put the answer in the chat, and I will tell you when to go. Okay, we have answers. You guys should be savvy with the calculator now. Okay, go ahead and press enter. Negative 4 is what we're looking for in this. So we already know from before that the square root of 169 is 13. So we're going to go negative 3 minus 13 over 4. Then a negative number minus a positive number is a negative number. So that is negative 16 over 4, which simplifies to 4. All right. So very well. Thank you all for your participation. Now we're going to do something a little bit different. I'm going to go back to Canvas. Oh my goodness. I forgot the whole note-taking part. No wonder there's extra time. Okay. Go ahead and copy all this down in your notebooks. I just want to make sure you have available all the steps to completely solve using the quadratic formula. Okay, give you a couple more seconds to get that down. Okay.
Mr. Guri, can you put a
Yes.
-4 on the right side?
Did I mess it up?
Just a negative in front of the 4, I think.
Oh, you are correct. Well, let me undo the box. Nope. Okay. -4.
Thank you.
Thank you. Okay, now we're going to do the basketball free throw challenge. This was originally a group activity. However, I decided that it would be best if we just all went through it together as one big group. Because there's a lot of steps. So first, we're going to watch a video that explains the activity. See, when I found this activity, I was so excited because I thought it was really cool and involved something other than just staring at math problems. But you see at the top here, this little message, this website is no longer actively maintained. So I had to come up with most of it myself, but we still get this video that explains what we're going to be doing.
I'm Elton Brand. I'm a power forward in the NBA. I'm here in my hometown, Peekskill, New York, visiting my old high school. I started playing basketball when I was about 5, 6 years old, and I was really, really bad. But learned the game and kept working at it and got better and better as I got older. I started out high school on the junior varsity team. Then the coach from the varsity team brought me up to that level. The following 2 years, we won the New York State Championship, which put me on the national spotlight and my team. So after high school, I accepted a scholarship to Duke University, got to college and played really, really well and became the #1 pick out of all the collegiate players and got drafted by the Chicago Bulls #1 overall. And it was a dream come true. As anyone that follows sports statistics knows, there's a lot of math in basketball. Free throw shooting is a skill that every basketball player has to work on. I don't constantly think about the math behind it when I'm playing a game. But when I was younger, understanding math helped me improve my performance. 3 key variables can influence your shot. First is the release height. Second is the ball's initial vertical velocity, a rate that includes the angle and speed of the ball as it leaves your hand. And the third is gravity, which makes a basketball accelerate as it falls. You can use these variables to figure out the height of the ball at any given time. And knowing that, you can tell if you'll make the shot. When I shoot a free throw, my goal is to maximize the height of the ball so it has the best chance of going in. Your challenge is to use the 3 key variables and my stats to figure out the maximum height the ball reaches on its way into the basket. At release, my average initial vertical velocity is 24 feet per second. My average release height is 7 feet. The free throw line is 15 feet from the backboard. The height of the basketball hoop is 10 feet off the floor, and the rim is 18 inches in diameter. And finally, you can find the height of the ball at each point in time by combining the 3 key variables. The acceleration of gravity, which is -32 t squared, but in this case, you'd use only half for downward pull, or -16 t squared. The initial vertical velocity, which you'd multiply by time to get the distance traveled, and the release height. All right, get to work.
Okay. I go back to our Jamboard here. Look at this. Elton Brand, by the way, retired from playing the NBA in 2016 and is the current general manager for the Philadelphia 76ers. Just in case anyone was interested. So he gave a lot of stats and a lot of measurements in that video, but we're only really interested in a few of them. So this is the equation that we're going to use to solve what the maximum height is of the free throw. So this quadratic equation is showing the path of a basketball free throw with t being the time in seconds. That's why it uses t for the variable and not x. With -16 showing gravity, 24 being the initial velocity, and 7 being the initial release point of the basketball. So that's when his arm going up and the ball coming out of it is at 7 feet. And we're finding the maximum height the ball reaches in the air on its path to the basket. So go ahead and write down this equation in your notes, just right below your other notes, because we're going to keep referencing it as we go through this. Okay. So the first step is we're going to solve this. We're going to solve the equation that you just wrote down using the quadratic formula. And here's the steps. Identify A, B, and C in the equation. Put those numbers into the formula. Simplify under the radical. Simplify the denominator. And calculate and write both answers. And our eventual answers that we're going to get here are both going to be fractions. So let's go over here. And the first step is that we are going to identify A, B, and C from that equation. So who could tell me what A is?
-16.
Sorry, did you say 16?
I said -16.
-16 is absolutely correct. All right, so then what is B?
24.
24. That's correct. Oh, look at that ugly looking 2. All right, and that means that C is equal to
17. I mean 7, sorry.
7. There you go. All right, step 1 complete. Now we're going to put the numbers into the formula. So we're going to start with, what are we starting with? It's that first term that's going to be outside of the radical.
The 24.
24, and because we're using the quadratic formula, that 24 is
Negative.
negative. Plus or minus the square root. I'm just laughing at my radical. Okay, what's the first term inside the radical?
24 squared.
24 squared, yes. Minus 4, that 4 is free. It's there every time. What's next? What is that 4 multiplying? 16. Close.
-16.
Negative 16. All right, what's the last term?
Times 7.
Boom. What's the denominator? And for 2 times something.
-16.
2 times negative 16. All right. So that's step 2 done. All right, now we're going to simplify under the radical. So we'll take the negative 24 down here, plus or minus the square root of, and then we're going to simplify under the radical on the right side here. So what is that first term? Go ahead and put that into your calculator. Someone give me what the first term is here. It's a big number.
576.
576.
576. 24 squared equals 576. Excellent. All right. What's the second term? Give you a hint. It's going to be another positive number.
Is it 448?
How did you get that?
I did the -4 times -16 times 7.
Very good. What was that final number?
448.
448. Okay. Okay. What do we get when we add those two together?
1024.
1024. Very good. What's the denominator?
-32.
-32. Very good. All right. Running out of room here. So let's finish this out here on the next page. -24 plus or minus the square root of 1024 over -32. All right, what's the first step now? Or sorry, what's the next step?
Finding the square root.
Yeah, we can do that. What's the square root of 1064?
32. I think.
1024. I say 34. 1024. It's 32, you think. Are you sure?
Yeah,
Uh,
she's right.
32.
Yeah.
Okay. I'm just
Yeah.
making sure that she's sure. All right, so 32. But now how do we get two answers from this? We have one expression and we need to get to two answers.
You add 1 and subtract 1.
Can you expand on that?
Like it would be -24 plus 32 and then -24 minus.
That's what I'm looking for. All right. So in the interest of time, because I don't want to rush through the next parts, because this is just fractions. This comes out to 1.75 and -0.25. So I was just going to have you plug that into the calculator. So let's go back here. So now our answers are 1.75, 0.25, negative 0.25. Okay, so now we're going to find the average. And I don't know if you've done averages before, but to find the average of two numbers, you simply add them together and divide by 2. So who could give me the average of the answers that we just came up with? .75, you think? I need you to be sure. Do we get a second on 0.75? You're sure it's 0.75? Well, you should be sure because that's correct. 0.75, that decimal point in there. All right, we're almost done. Now, the last step in this is we're plugging in that 0.75 into the original equation for t. All right, so this is 0.75 and 0.75. All we're doing is where there was t in the original equation, we're putting in 0.75. So that's negative 16 times 0.75 squared plus 24 times 0.75 plus 7. Anyone tell me what that answer is? Anybody got this in the calculator? Give you a hint. I'm pretty sure some of you are this many years old.
16.
16. So looking at this picture, that is that point right there on the arc of the ball. I have graphed this equation in the Desmos calculator. Now we can see right there at the top, the maximum point, the vertex, is 0.75 and 16. That means at 3/4 of a second, the ball reaches its maximum height of 16 feet, and then starts heading back downwards towards the hoop. Very good, everyone. So now I'm going to go over your async assignment. Okay. The first thing you're going to notice, there's a whole bunch of words on this page, and that this is a lot different from your usual async work. So I've extended the deadline. Usually all your assignments for the week are due on the coming Sunday at 10 a.m. This one you get an extra week. So this is not due this coming Sunday, it's due the following Sunday at 10 a.m. And I have not worked this out with Ms. Schmitz yet, but if we have some spare time next week, I want to kind of go over this again, briefly. We'll see. So what you're going to do in this async assignment is basically everything you just did. It's basically that free throw problem. It's just a little bit different. And there's one extra step. 2 extra steps. All right, so we're starting at the top. As part of the halftime show at the Lakers game, a t-shirt cannon is set on the ground at half court at Staples Center. It launches t-shirts into the crowd for fans to catch. The effective gravity on the t-shirts in the air is the same as it always is, -16. The t-shirts are launched with an initial velocity of 64. And since it is on the ground, the initial release point is 0. So from that information, you're going to create a quadratic equation. That is the first step here. Now go back into that Jamboard, and that link to the Jamboard is going to stay in Canvas, and look at the first slide of this, which I think is slide 5. That will help you craft this quadratic equation. The second part is that you're going to solve it, like we just did. Then you're going to find the average of the 2 zeros, and that average will give you the x value of the vertex. You're going to plug that average into your equation that you wrote in step 1, and then that'll give you the maximum height. Okay, this is all the same so far. The next part is that you're going to draw a graph of the parabola. Now, when you do that, you're already going to have the 2 x-intercepts. You got them in part 2. And then you have the vertex, which is the average from 3 is the x point or the x coordinate, and then the y coordinate is the answer in part 4. So just put those 3 points on there and then draw a parabola. And make sure to label the coordinates. And then the last part, saying overlaying a graph that you drew above on the seating chart at Staples Center, and then lists 3 people who are sitting at different points. Which of them will catch the t-shirt? And it's basically asking you which of these points is actually on the parabola. So this isn't worth a ton of points, and we're looking for the process. We're looking at how you're working through all the steps. Okay, if you make a mistake in the calculations, that's fine. You'll still get full credit. Don't stress too much about accuracy, but we want to see you working through all the steps on this assignment. You have an extra week. We're going to go back again for anyone who wants, for the whole class can get some extra time looking at this. So I just don't want you to stress out. Okay. Thank you so much, everyone, for your participation today. You know what your async work is. You are now all dismissed. Chapter 3 retake tomorrow. Get the assignment.